Now, in this lecture video, we're going to look at what's called the 5-number summary. The 5-number summary consists of 5 summary statistics that we've already looked at. It contains the 2 extreme values, the minimum value and the maximum value in the data set. It also includes the 3 quartiles, so Q1, Q2, and Q3. Now, a graphical representation of a 5-number summary is called the box plot. And so the structure of a box plot, or of a basic box plot, consists of a box here. And this is a vertically oriented box plot, obviously. The lower end of the box is at the position of the 25th percentile. The upper end of the box is at the 75th percentile. And then within the interior of the box, we have a horizontal line at the position of the median. So we need to think that we have a vertical axis here. And so we are plotting the locations of the ends of the box as well as that line in the middle relative to that vertical axis. And then what we do is we take the minimum value and the maximum value in the data set, and we plot the locations of those values relative to that vertical axis, and we extend lines from the edges of the box to the extreme values. And so again, this gives us a really nice graphical representation of the values in a 5-number summary. Now with this, we have several measures of location, obviously. We have the location of the minimum value in the data set. We have the location of the maximum value in the data set. We also have the locations of the values for the quartiles, including the median of the data set. We also have 2 measures of variation. We have both the range, which is represented by the distance from the lower whisker to the end of the upper whisker. Okay, so that's the range. And then the interquartile range is the length of the box. So we have graphical representations of 2 measures of variation for a data set with a box plot. Now typically we also have plotted somewhere in the box the location of the mean of the data set, which is typically indicated by a plus sign. And so different software packages do these things a little differently, but typically if you construct a box plot using SAS or with Minitab or R or something like that, typically it would look something like this. Now there are more complicated ways of constructing box plots, but I'm not going to show you those. If I construct a box plot, I always construct this simpler version, which I've got here. Now let's look at some examples here. So we have the following slide gives the emergency room charges for samples of patients from each of 2 city hospitals. And so the question I want you to think about when you look at these 2 data sets, which we're going to show side by side, all right, so that we can try to compare them. But the questions I want you to consider are which hospital appears to have higher charges, which hospital appears to have greater variability in its charges, and how are the data distributed? Can you get a sense of the shape of the distribution of the data by looking at the data sets? So we want to think about those questions. And so here are the data, the emergency room charges for the 2 hospitals. All right, this data has not been processed at all, so we've not even sorted the data. And so if we were to ask the question, which hospital looks like it has greater hospital charges, which of the hospitals looks like it has more variability in its charges, and could you begin to identify the shape of the distribution of the data? I think that all 3 of those questions would be somewhat difficult to answer because the data have not been processed at all. So what we want to do is we want to create data arrays for each of the 2 data sets. And so for each hospital's data, we've created an ascending data array. And so then if we were to look at this and try to answer the question, which hospital appears to have the higher charges, then depending upon which values you look at, you might choose either one of these. So for example, if we look at the minimum values, we see here that hospital 2 has the larger of the 2 minimum values. If we look at the middle value, we see that hospital 2 also has the larger of the 2 middle values. On the other hand, the largest value is greater for hospital 1 than it is for hospital 2, but overall it looks like hospital 2 tends to have the higher charges. On the other hand, if we try to get a feel for the variability of the two data sets, while we can look at the range of the data sets and get an idea, it can still be difficult to discern, but it does look like, at least using the range, that the hospital 1 has the greater of the two charges. And in terms of the shape of the distribution of the data, well, that's fairly difficult to get with just a data array. So now we're going to process the data and summarize the data using a 5-number summary. And so here we have the minimum, the maximum, and the 3 quartiles for each of the 2 data sets. And so we can begin to get more clarity of the first 2 questions at least. Which of the 2 data sets looks like it has tends to have the higher charges, and which of the hospitals tends to have more variability. And so we can see here that it does look like overall, really for 4 out of the 5 statistics here, it looks like hospital 2 has the greater of the values. And in terms of variability, if we do some mental calculations, we may be able to come up with an idea of which of the 2 hospitals has more variability in its charges. But we may have to break out a calculator, and so even that question is not very easy to answer. And I would also say that I think that it's difficult to, personally think it's difficult to assess the shape of the data sets with these values just looking at them like this. But if we construct side-by-side box plots, then we can see here very easily that hospital 1 does appear to have much greater variability than hospital 2. Hospital 2 does tend to have the higher charges, and there does appear to be a little bit of skewness in each of these. Perhaps the data are less skewed for hospital 1 and for hospital 2, but that can be difficult to tell sometimes with box plots. It may be easier to discern with something like this, where we have a histogram. Now, in looking at the histogram, we see that the data are not unimodal. We have bimodal data in the hospital charges, and that makes sense because we have 2 hospitals. All right. Well, I'm sorry. This is hospital 1. So even within hospital 1, we have bimodal data, and that may be a function of the fact that maybe we've got 2 broad categories of types of procedures that occur in the hospital. Some that are less expensive, some that are more expensive, or something like that. And I think that because the data are bimodal, I think that's what makes it difficult to discern from the box plots the shape of the distribution. When we do have bimodality or multimodality in general, then it does become more difficult to talk about the shape of a data set, even with a histogram like this in terms of skewness and so forth. But so this is for hospital 1, and again we see 2 modes, and we may have some left skewness there. Here we have histograms or a histogram for the charges for hospital 2, and again we do have some bimodality, and again that could reflect the fact that we may have 2 groups of types of patients getting different charges or something like that. All right, now in addition to the 5-number summary, we also calculated some additional summary measures, the means of the 2 data sets, the standard deviations, and the interquartile ranges. And so we see here that based on the mean as a measure of location, we see that hospital 2 does have a higher mean charge. In terms of variability, we see that both the standard deviation and the interquartile range would indicate that hospital 1 has the higher variability. And so you see here that with these different summary statistics, we can begin to glean some useful information about characteristics of the data set, where the data is located, how much variability there is, and if we construct graphics of the data, then we can begin to understand the shape of the data set in terms of its modality and potentially its skewness as well. So that is the end of this particular section in the notes. In the next section, which is kind of an addendum to the notes on descriptive statistics, we're going to get into a little bit more mathematical notation We will introduce the notation, get you familiar with that. I know that you've already seen it, but I want to refamiliarize you with that data or with that type of notation. And we will go on from there and look at some of the details of the calculations and some properties of those kinds of calculations.